Hello, and welcome to Relaxing Facts. I'm Chad K, and today I'll be talking about thermodynamics. Each week, I share interesting stories and little-known facts on a variety of topics, accompanied by gentle, soothing music. My goal is to help you find a sense of calm during your busy day. Feel free to settle into a cozy spot and let yourself be carried away by these relaxing facts. Thermodynamics may sound intimidating, like something reserved for scientists or engineers, but it is much more approachable than it first appears. By the end of today's episode, you will see that thermodynamics is not just about equations in textbooks. It is a story about how the world works, why time seems to move forward, why no machine can run forever, and even why life itself is possible. The word thermodynamics comes from the Greek words for heat and power. At its core, thermodynamics is the study of how energy moves and changes form. Every time you warm your hands by a fire, sip a hot cup of tea, or watch ice cubes melt in a drink, you are watching thermodynamics at work. You can think of thermodynamics as the science of energy bookkeeping. It tells us where energy goes, how it is transformed, and what limits exist in the process. Energy is the currency that runs everything in the universe, and thermodynamics is the set of rules that determine how that currency can be spent. Thermodynamics is built on four main laws. They sound simple at first, but their consequences are enormous. The first is called the zeroth law of thermodynamics. It was discovered after the others, but was considered so basic that it was placed at the very beginning. It says that if one object is in thermal equilibrium with the second, and that second object is in equilibrium with the third, then the first and third are also in equilibrium with the other. In everyday language, if two objects are the same temperature as a third object, then they are also the same temperature as each other. Without this principle, the very idea of temperature would not make sense. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed from one form into another. When you burn fuel in a car, chemical energy is transformed into heat and motion. When you charge a battery, electrical energy is turned into stored chemical energy. No energy ever disappears. It simply changes its form. This is why machines that promise to create energy from nothing, so-called perpetual motion machines, are impossible. The second law of thermodynamics is perhaps the most profound. It tells us that in every natural process, the total entropy of a system increases. Entropy is often described as disorder, but it is more accurate to think of it as the number of possible ways a system can be arranged. Hot coffee in a cool room always cools down. It never spontaneously grows hotter. Your phone battery drains as you use it and never magically fills itself. The second law gives us the arrow of time. It explains why events move in one direction, why broken eggs do not put themselves back together, and why life involves a constant struggle against disorder. Finally, the third law of thermodynamics tells us that as a system approaches absolute zero, which is the coldest temperature possible, about minus 273 degrees Celsius, its entropy approaches a minimum. At that extreme cold, disorder is reduced to its lowest possible level. Yet absolute zero can never actually be reached. It is like a finish line we can move closer to, but never cross. Together, these four laws form the foundation of thermodynamics. They are not inventions of human imagination. They are the rules the universe itself plays by. Although these laws might sound abstract, they are alive in our everyday experience. Consider your car engine. It is a thermodynamic machine that takes the chemical energy in fuel and transforms it into motion that moves you down the road. Airplanes and rockets work on the same principle, only on much larger scales. Your refrigerator is another example. It keeps food cold not by creating coldness, but by moving heat from the inside of the fridge to the air outside. If you place your hand on the back of the fridge, you can feel that heat being released. Cooking is full of thermodynamics as well. When you slowly simmer a stew, heat energy breaks down proteins and softens the food. When you bake bread, heat causes the dough to rise and transform into a golden crust. Even the act of boiling water or melting chocolate is an everyday reminder of how energy changes matter. Your body is itself a thermodynamic system. The food you eat is chemical energy, which your body converts into movement, heat, and thought. Every breath you take and every beat of your heart is part of the great cycle of energy. Even sweating is thermodynamics at work, since evaporation carries heat away from your skin to cool you down. Thermodynamics also plays a role in global systems such as our climate. The Earth's atmosphere absorbs energy from the sun and redistributes it through winds and ocean currents. When we add greenhouse gases to the atmosphere, we change the way heat is trapped, which leads to global warming. In that sense, climate change is not only an environmental problem, but also a thermodynamic one. The beauty of thermodynamics is that it does not stop at the scale of daily life. It extends outward to the cosmos itself. Stars shine because nuclear fusion converts mass into energy. But even these enormous powerhouses are bound by thermodynamic laws. Over time, stars burn out, galaxies spread apart, and the universe edges closer to what scientists call heat death. This ultimate fate represents the second law on the largest possible scale. As energy spreads more and more evenly, differences in temperature disappear, and with them, the ability to do work. In such a universe, nothing would change because no energy would be available to drive change. It may sound bleak, but it is also profoundly revealing. Thermodynamics gives us a kind of cosmic clock. It shows us not only why things happen, but also why they cannot happen in reverse. It explains why time feels one way, and why energy is both our greatest resource and our ultimate limitation. What makes thermodynamics so fascinating is not just its ability to explain the physical world, but also the way it touches on philosophy and human curiosity. It sets the boundaries for inventors and engineers, challenging them to design machines that are as efficient as possible, but never perfect. It reminds us that there are limits to what is possible, but also that within those limits lies endless opportunity for creativity. It also reminds us of our place in the larger order of things. Every thought we have, every meal we eat, and every step we take is part of the ongoing story of energy. We are participants in a vast thermodynamic process that began long before us and will continue long after. So the next time you enjoy a warm drink, walk into a heated room on a cold day, or watch the sunset, take a moment to remember you are witnessing thermodynamics in action. It is the invisible framework that shapes reality, the quiet set of rules that make the universe understandable. And that brings us to the end of this week's talk. If you liked this episode of Relaxing Facts, I would love for you to subscribe or leave a comment. I hope you have a fantastic day, whether you are taking a moment to unwind or simply enjoying some calming listening. Thanks so much for being here. I'm Chad K, and I look forward to seeing you next time. Goodbye.